do it by graphing. So I know this one was in that graphing homework, but in this one, if we are looking at adult and children's tickets, how many total tickets did we buy? How many people went? 11. That means the adults, this is one equation, plus the children equals 11. Someone said, oh, but Mrs. Thompson, when I did that, I did x plus y equals 11. Same thing, right? You just have told me that maybe the x is your adults and the y is your children's ticket. But you want to tell me that. If not, it makes sense to use the variable that word starts with, because that's what you're trying to find me. How much was the cost of each? How much did they spend total? They spent $228. 228 is equal to how much was each adult ticket. So this is the number of tickets that we bought. This is the value. You will be using this type of an equation many times when we do our story problems. And I don't know if you've looked, but after we finish elimination, there's like pages of story problems, right, in your workbook. It's like that's all there is. It's like 5 pages of story problems, right? And we get into these mixture problems, and people kind of freak out on the mixture problems. It is simply writing an equation first with a number and then with the value. Like how many milliliters of something and then what's the percentage of something. So they're not bad if you can kind of keep thinking of them in this way. So in this case, the value of the adult ticket was what, Owen? How much was our adult ticket costing? So we're going to have 22A. Plus the value of a children's ticket, then Caden, behind him is how much? Right up here.
Oh,
15C. These are my 2 equations that I'm looking at. Now, would it make sense for me if I was looking at those 2 equations that maybe I'm going to take the first one and solve for A, and A equals 11 minus C, and now I'm going to go to this equation and substitute. So when you substitute, you're keeping the equation the same, 22, but instead of A was equal to 11 minus C. I still have plus 15C, and I still have the equal to 28. I just replaced it. Just like when I was gone, there was someone that replaced me. I heard they weren't quite the same as me, but nonetheless, they substituted it, right? By the way, thank you for being appropriate, and I heard there was some visiting and talking, but this class much better than everyone else, so thank you. All right, so then we would finish solving this. Do I need to finish solving this one? Do we need to go through it, or yes or no? Yes, let's go through this one. So take 22 times 11, please, on your calculator, or just looking at that one. 22 times 11, what do we end up with?
231.
231. Minus 22C, right? Plus 15C equals 228. I want to add my like terms together. Some of you, I would strongly recommend that minus keeps giving you a problem, change it to plus a negative. If that minus is giving you a problem, change it to plus a negative. So we have negative 22C plus 15C. If I am adding those 2 together, Ben, what do you end up with?
37. No.
Signs are opposite, right?
Yep.
So 22 minus 15 gives us?
17. Oh, no. Something else. That,
Negative 7?
yeah.
228. All right. Caleb, what are you going to do next?
Add 7 on each side.
I could, but let's just get negative 7C by itself. That's okay if we have a negative 7C. What could I do to that? Because I want to go less steps. Subtract 231, right? And when I subtract 231, it should come out negative. What am I ending up with, Lainey, when I take 228 minus 231? Was it 231? I'm thinking that this doesn't seem right.
Yeah, 242.
242, yeah. As I said, this seems way too small. Okay. Thanks for reporting out their numbers. So we're going to take 228 minus 242, which does look better to me. What did we end up with?
Negative 14.
Negative 14. And you divide it by negative 7. And we get 2 children's tickets. Now, if children is 2, what do the adult tickets have to be? Way easier to go to the first equation, right? I have 2 children's tickets and 9 adult tickets, right? And if I check that, right now on your calculator, please take 22 times 9 plus 15 times 2. Do you get to 28? That's how you want to check it, not the answers in the back. You want to do that quick check as you're looking at it. Geometry problem. You got measures of the 2 acute angles in a right triangle. You're going to see this again in some of our story problems when you do it. Here's our right triangle, right? We don't know the measure of this angle and this angle. If it helps to draw a picture, right? That's a right triangle. We have these 2 acute angles, and it says 1. Now, my picture isn't really drawn to scale. Angle is 4 times the other one. Do you want x to equal 4y or y to equal 4x? Does it matter? Tell me which one you want me to put down. X equal or y equal? Y equals. This angle is 4 times the other one, which means the x angle is way smaller, right? Okay. What do you know these 2 angles, all 3 angles in a triangle add to 180. What do the 2 add to? To 90. X plus y equals 90. These are my 2 equations, right? So nice for substitution. I'm going to put x plus, but instead of y, I'm putting 4x equals 90. 5x equals 90, and I'm dividing by 5. 90 divided by 5 gives me how many? 18. So it says, write an equation, find the measures of the acute angles. This one is 18 degrees. The other one is 4 times it. So y is equal to 4 times 18. Someone else said, oh, couldn't I have just taken 18 away from 90? That works too, right? Because that's what x is here and that y would equal. So it doesn't matter which way you solve it, right? So we should have 72 degrees. 72 plus 18 equals 90. 18 times 4 gives me 7. Okay, so there's many ways of solving. Okay. So what I do want handed in is the graphing one. And substitution, right? And graphing. Page 9 in your notes. Okay. So up to this point, you did see in both of these that you could have no solution, right? Okay. If you have no solution, what does it look like when you're doing the substitution? No solution. That's when what? 0 equal 2. Okay. When you graphed, no solution was parallel lines, right? Just to make sure. Okay. No solution when we did substitution was when you had 2 numbers that were not true and then parallel lines. If we were looking at all real numbers when we were solving would be something like 0 equals what, Gavin?
0.
Only one option, 0, right? And when we graphed them, it was the same line, right? One line on top of each other for all real solutions, right? Okay? So just so we're clear on that. All right, so look at this system up above here, top of the next page, okay? Or that next page going down. 2x plus 5y equals 17, 6x minus 5y equals -9. Wouldn't this be so ugly to do substitution? If you had to solve for either x or y, you would have tons of fractions, and many of you would make mistakes. So they have this other method. It's called the addition or elimination method. And the key thing I want you to take a look at is it says we want to eliminate one variable. And in front of the y's, what do you notice? One is a positive 5 and one is a... And if you add those 2 together, you get 0. So that is what we're going to do with our 2 equations. We are simply going to add them. We're going to find the sum we're going to add. But you always have to make sure one of the coefficients would be 0. So we add 2 plus 6, it gives us 8x. equals 8. 17 plus negative 9. Isn't this beautiful? X equals 1. We're almost done. We plug the 1 into the equation. They chose the first equation. 2 times 1 plus 5y equals 17. Subtracted 2. Got 15 divided by 5 and got 3. Our answer is still an ordered pair, 1, 3. Okay? So it says, which variable can you eliminate? You can eliminate either variable. You want to choose a coefficient for y that are opposites and then add your equations. Okay, so that's what we are going to be looking at doing. You still want to do the check. So we look at these two equations. Right? So top of the next page. Some of you aren't there yet. 1a, right, you agree, plus 1m equals 101. 2.5a plus 1m equals 164. Now, they talk about subtract. I will tell you subtracting is the same as doing what with this whole equation? Multiplying everything, adding the opposite. So we're going to think of multiplying everything here by a negative 1, right? If you multiply everything by a negative 1, that leaves us with negative 2.5. It's going to leave us with a what? Negative 1m and negative 164, right? We're taking everything times negative 1. Well, look what happens now with my m's when I add those. 1m plus negative 1m, 0. A minus, so that's 1a minus 2.5. That leaves us with a negative 1.5a. Equals 101 minus 164 leaves us with a negative 63. I now have negative 1.5a equals negative 63. I want to divide on both sides by negative 1.5. If I do that, Abby, what'd you end up with? We should have 42. So someone said, how do we list our answers when there's not x and y and it's a and m? Usually you can always put them in, anytime you're doing an ordered pair, in alphabetic order, so it'd be a comma m. But you could leave a, but now we still got to find m. Which equation's easier to find m, the first or second? The first one. So go to the first one, right? Someone said, do I have to write that down and show it? Well, for some of you, I definitely would at the beginning. I would put 42 plus m equals 101, and I would subtract. Because some of you, the computational errors, I will tell you, for the people that are coming in and getting help, that's where people are making mistakes. It's not on, like, getting the problem. It's making computational errors. So we should have 59. And could you do a really quick check? So on your calculator, we want to just check it to see if we did it right. How are we going to check? We're going to go to the second equation. So in your calculator right now, take yours out and type in negative 2.5 times 42. Plus, oh wait, it wasn't negative 2.5 in the original, right? It was a positive 2.5. Got your calculator, Gavin? Here's one up in front. Grab one. Plus, if we are doing this one, 59, right? And the question is it equal to 164? Did it work?
You can check it with the first one because you have 100 minus 42 and 42.
You can't check it in the first one because you use the first one to solve. And that's the mistake. It will definitely work in this one. And that's the mistake that some people did when they were doing the substitution. They got this answer using the first equation. And then to do the check, they used the same equation. Well, of course it's going to work. You just solved for 59 in this one. So if you plug in 59 and 42, it's going to work. So you can't use the same equation that you just used. You have to use the other one for the check. Okay? It will not work. I mean, it'll work perfectly, but you don't know if you did it right. It'll always work because that's the one you use. Okay? So let's take a look at this system. So again, we're going to try and eliminate. So I have negative 2x plus 15y. We can't eliminate the y's right away, right? But we can, because the signs are opposite. So when you do the elimination, you want one to be positive and one to be negative. And you need the number to be the same. And we know that if we multiply the whole equation, every single thing in that equation, they are equivalent equations. So what they did is they said, okay, let's take everything here and take it times 3. So 3 times 7 gives us 21. 3 times -5 gives us -15y. And 3 times 17 gives us 51. So 19x plus 0 equals 19. X is 1. We're going to go back and solve. We get y is 2. The question is, why are we multiplying by 3? And our reason is we want to have the coefficient. Write this down, please. Some of you, if you write with us, then we don't have to wait. The coefficient of y to be the same number and opposite sign in order to do the elimination. And because we had this one being a positive 15 and this was a negative 5, I can multiply them both by 3, multiply that second one by 3. Now some of our equations today, you're going to start, you don't have to multiply by anything. Some of them you have to multiply both equations. Some of them you might only have to multiply one equation. The key thing is pick a variable you want to eliminate and make sure the number in front is the same number by using multiplication and the signs are opposite. Okay? So take a look at these two equations. First off, they're not set up in the right form, right? When you do elimination, you got to have the x's, the y's equals the numbers. So rewrite the equation so that all the terms are in the columns before trying to solve. Next, multiply. So we're going to do a little work, so make sure you start over here. That first equation, I'm going to have to add 3x, right, to both sides. And then I'm going to have to add what to both sides? Add the 1, right? Because we want the x, and we're going to put, since this equation is 4x, we're going to keep it in that same order. We're going to put 3x plus 2y equals 1. Second equation, 4x. Write it out. Plus 3y equals -2. And I'm hoping some of you will make some of those key errors that you've made in your homework so that we can kind of show how you can check things really carefully. So first thing we want to decide, which variable do you want to eliminate? Does it really matter in this problem? No. So Whitney, you get to choose for us, x or y? Y. So I'm going to put this arrow over the top because that tells me which one I'm eliminating. Now if I'm going to eliminate the y's, I need the coefficient in front of y to be the same. I need them both to be a 6. But I need one to be positive 6 and one to be negative 6. So if we are starting off, reckon which one do you want to be the negative? First one or second? Second. Okay, so the first one we're going to take times 3. The second one we're going to take times -2. We're going to start multiplying. So Jack, if we start multiplying, what am I going to have for my new first equation?
9x plus 6y equals 3.
Yes. Abby, then the second equation.
-8x minus 6y equals 4.
Okay. So now we're adding. If we're adding them, Abby, what are you going to end up with?
X equals 1.
X equals what?
-1.
-1. Wait, did you have this as a -4? Okay, so let's just check.
7.
It was a -2, and you multiplied by -2.
+4, but do you think it should be -1?
7.
7. You sure? Could we just finish solving and see if we did it right? Or do you want to get it right? So, mistakes like this, even with the 3 and 4 here, people go, yeah, but aren't we subtracting the 2? The signs are opposite, you are adding. As long as the signs are opposite, that's what I would suggest, always add it. So this should not be 1, but it should be 7. Okay? Okay. Yes?
Never mind.
Negative times a negative is +4, right? Okay, so if you would have got -4 here, I agree it would be -1. All right, Katie, which equation, going back to your originals, would you like to use to solve for y? First one. So, first equation is 2y minus 1 equals negative 3x. So tell me what I should write down. You know x is 7.
2y minus 1 equals negative 3 times 7.
So Josie, we're going to keep going. We get 2y minus 1 equals negative 21. Add 1. What did you end up with?
2y equals negative 3.
Okay. Sanjay, what are you doing next?
Divided by 2 instead.
Okay. Gives me
Y equals negative 10.
y equals negative 10. So now I want to check in this equation. And some of you are like, I don't need to do the check. And this is where you can't check it in the first one because you use that one. It will, 7 and negative 10 will definitely work. So we go to the second one. And we put 4 times 7, 28, plus 3 times negative 10. So 28 plus negative 30, is that going to give us negative 2? It checks, it gives us negative 2, right? It has to work in the other equation because it will definitely work in the first one. And if we would have got negative 1 here, we would have seen lots of places where we would have had mistakes. But you can go back. Don't erase everything. Don't erase every single thing you've done because a lot of times it was just like this, negative 1, and you change it to a 7, and then you change over here to a 7 instead of negative 1, and everything works out beautifully. Don't erase everything. All right. So, next page down, we're going to do the elimination. First equation. Do we love it?
Yeah.
Yes. Which variable would we eliminate in first equation? The y's. Please add those together and be ready if I call in. The second equations, second set, you have to multiply one of them by negative 1. All right, Elena started in the first one. What'd you get?
8x equals 16.
Okay. Next step, Mallory, would be to
Y by 8.
and
X equals 2.
okay. First part of my answer, 2. Then what am I doing, Jacob?
Putting in 2 plus x.
Which equation?
Second.
Okay. So 3 times 2. Right? We're going to subtract 6 from both sides. Do you agree? 3 times 2 is 6. So I end up with 6y equals 42. And y should be 7. 5 times 2 is 10. 10 minus 42. Does it equal negative 32? Checks. I don't have to look in the back. I just checked it in that other equation, right? So I'm looking at that. All right, so we're looking at that next equation. Which one do you want to multiply if we are looking at it? First or second by negative 1?
First one.
First one by negative 1. We multiply everything by negative 1. Now, someone said, can I just in the problem then when I write it down change this to a positive and this to a negative and this to a negative? That is what happens when we multiply by negative 1, right? And so now it's super nice to add together. We were maybe going to eliminate the y's or the x's because what happens? 0, they both cancel out. 0 equals?
So it's no solution.
So it is no solution. Can't do anything, right? All right. Are you ready, Liz? Which variable do you think might be easier to eliminate, x's or y's? That has opposite signs. The y's are going to be easier. So, I need to have a 6 in front of both of them, right? We're going to multiply the first equation by 2 and second equation by, do I want to go negative 3? Or can I just go through? Just 3. All right, Soren, tell me my new equations that I'm going to write down.
8x plus 6y equals negative 38. And then 9x minus 6y equals negative 30.
Making sense to everyone? Don't forget to distribute to this last one. That's probably the most common mistake. I'll get like a -10 back here. Katie.
I'm confused. How do you find your starting numbers? Like, how do you find that?
So I might look and see, oh, these ones have opposite signs. And because they have opposite signs, I want to eliminate the y. So I need a number that both 2 and 3 can go into. So 2 and 3, the smallest number they multiply into is 6. So since I want a 6 in front of my y, I'm going to take the first one times 2 and the second times 3. Okay. Good question. So we're going to add those together. If we're adding those, Jacob in the front, what do you get?
17x equals 68.
Yep. I'm going to divide both sides, 17. Owen, did you get it for us yet? X equals?
X equals 7. Oh, X equals 68.
Nope, we got -68 divided by 17. That's what I was hoping you were doing for us. Negative divided by positive is always going to be negative. In this case, we should have had,
I did divide by 17.
What? Should be -4. Did you get x equals -4? Or what?
I did subtraction for mine.
Yeah.
Oh, wait, no, I messed up doing that.
All right. Will you make sure you write down the notes just like I have up here?
Yeah.
Okay.
I did subtraction initially trying to start that. So.
Yeah. I can't do that till they're the same. So please do them like we are. And then when we go to do your homework, then we can kind of look at that. But as we look at this one, so we got x is -4. Taylor, where are you, which equation do you want to get my y? Okay, second. So we're going to go with 3 times -4. Okay, keep going.
Minus 2y.
So I have -12 minus 2y equals -10. So easy to make so many computational errors for you guys. Plus 12. We get -2y equals 2, and y is -1. I am still looking at your solution being an ordered pair where you tell me -4, -1. On the quiz next week, all answers must be as an ordered pair, unless it's a no solution or infinitely many. If you graph, if you use substitution, if you use elimination, all of them will be an ordered pair. We did not do the check on this one, but could it be, since we used the second equation, right, it could be pretty easy to go to the first one and say 4 times -4, that's going to be -16, right? Plus 3 times -1, that's going to be -3. Yeah, that checks and gives me -19. It's that easy to do the check. It's probably quicker than turning to the back of your answer key to look at it. As you look at your homework, if you turn to page 382, you're doing 7 to 25 odd. I would like to look at every answer will be an ordered pair unless, here you go. Unless I am looking at infinitely many or no solution. When it says tell whether there is one solution, if there's one solution, you're going to give me the x, y. You want to actually solve it all the way. Okay? So, on your paper, you're going to write the problem. I would leave space to do the whole problem going down and like have half your page doing like the problem going down and then, okay? The first one starts off pretty easy, right? You should be able to do that one probably without too much. So start there. Tomorrow we're going to do more of this. It's a D4, okay? I had a couple people tell me they're going to be gone. On Monday, we are looking at doing the D4B, and I think that on Tuesday will be our quiz, okay? So the D4B is graphing, substitution, and elimination. I put all of them in, okay? So this D4 is more elimination. Monday's gonna be practicing all three. If you don't have the first two down, please come and see me. Tomorrow we'll practice more. Tomorrow we will probably have a small homework quiz on either graphing or substitution, just to kind of see how you're doing with it. If you don't get that, come and see me. 7 was really nice, right? Can you just add them together right away? The y's cancel, right? When you put it on your paper, the y should have canceled. Some of you haven't started writing. You should be starting. You should have number 7 almost done. Remember, you have to have an x and a y. It's so easy to get the x equals and people stop. Because it's like, oh, I solved it, I'm done. Remember, 2, x, y, x, y. Always have to have the 2. I know 13 will give some of you a problem. We're going to come back to all those story problems, and you'll even see this one in our review. So we will go over it. If you don't get 13 solved, if you could even just write the equation, that would be a good practice, okay? The other day I had someone with their homework on D3 when I was checking yesterday when the counselors were here. And when I was checking Sanjay's, and he had answers and no work, no credit, right? There's no way you're doing the substitution and just looking at it and going, oh yeah, 3-2, or no solution, or infinitely many. There's no way. And if you are, I'm going to give you the quiz or the test and see if you can just do it with any work and just give me the answers too. So I really need you to show the work. Any big questions as you look at these? Of what you multiply by or how you do them.